Hello, everyone. My name is Janar Garcia, Technical Marketing Engineer at Fortanix. I'm here today to do a quick introduction of the tokenization feature that we have at Fortanix. And before we go to the details here, I would like to quickly discuss the different types of technology transactions that we've been blessed with over the past years, where we could call into our telephone using our telephone system, our cell phone, to basically acquire information about our bank accounts, what's our balance. Um, we can use computers, our laptops, desktops, our tablets to basically view, what had happened to some of the transactions that we have. And we can also do voice recognitions where when we purchase something, as an example, through Amazon, it can keep all those credit card information to a digital wallet, which basically links to a voice recognition platform, which basically makes it easier to purchase uh, products using voice recognition. But the biggest problem that we have here is that as we transfer those sensitive data across the internet, do we really know how these sensitive data are being saved, how they are being protected from the bad guys? Because if you really understand, how sensitive this can be, it can be somewhat a burden, financial burden. If someone acquired this information over the internet and they have your social security number, you have your credit card, it's going to be very painful to each and every one that has been hacked. The purpose of this is to basically provide the idea that, when we use these types of services, are we really are the providers that providing these services to us really providing a secured infrastructure so that our financial information is not gained by the bad guys, the hackers itself, that they could use for their financial advantages. So in some of these databases, there are multiple ways to protect these databases. And these are the different levels, which is basically a perimeter level, which combines VPN access. There's also firewall access. And then access levels, which is basically providing the access control list for people that can come in, or IP address that could use the services to gain information to a specific database. This also includes permission, login credentials. If they could basically, if they have the permission to access specific data, then good for them. If not, if they're not needed to access the data, then they should not be. So these bad guys can try all different ways to gain access, but they can only do certain specific access to specific information, because the main goal that they're trying to access is the database level, which is where the critical and sensitive information that an individual or business resides, which could be social security, employment ID, credit card information, health records, and all these things. So the bad guy could hang out within the perimeter level and the access level for a long time and wait and wait for many days to try either a brute force or a dictionary attack for this database just to gain access, because this is the root of all the information they need to take over a platform. Credit card information, social security, this is all what they need. So there are different levels of protection, as you can see here. And with Fortanix, we have the capability to provide masking, which is a set of protection where a whole string of digits can be masked so that it does not reveal the entire string of digits, so that you could use it, or a bad guy could use it for purchasing some stuff on the internet. There's also capability of encryption. And then we have also tokenization, which is basically the main topic of this presentation. Now, before we go into the details, let's talk about what is tokenization. So tokenization is basically taking a sensitive piece of data, like I said, so security number, credit card information, and substitute the data with a non-sensitive data, which is basically the token that can be used freely, shared to anybody, which it can't be hacked. And I'll tell you more details in a moment. So common use cases of tokenization. The first thing is that when you use our tokenization platform, it reduces the compliance issues in terms of data subject to compliance requirements, since tokenization cannot never be replaced or irreversible. Whereas in other features where encryption, which I'll cover later on, you can actually reverse them. And then third-party sharing complies with the GDPR requirements because data should not be copied or moved within different locations. It should reside on the same location. So it suffices the requirements of third-party data sharing. In addition to that, it fortifies access control. It assures that only specific people can access the specific data. When I say specific data, it's sensitive data that's being used to purchase things on the internet. And also, it improves overall security posture. It guarantees that your customers using your service, if I'm saying as a provider, that their sensitive data will never get into the bad guys' hands, because once they gain access, that would be it. They will be you'll be all over the news, and you'll be, as a company that does not comply with this, you'll be hit as a bad guy that does not protect data information of customers. So how does tokenization works? And so what we do is that we take sensitive data and we tokenize it. And that tokenized value can never be irreversible or replaceable, as I mentioned before. And there's two types. With tokenization, the first one is that you tokenize the key, and we use an algorithmic approach, and we generate those tokens from sensitive data. So basically, we use them, and basically you could store it in a database so that you could, when the information or raw data is required, it goes to a database where it's basically linked to sensitive data and the database information. And then we also have other ways to do it, where we use the same tokens, we tokenize sensitive data, but we use what we call format preserving encryption, FPE, which is a standard. And I'll tell you more, which leads us to the differences between what is a boltless and a bolted tokenization. So before we start here, I want to let you know that with Fortanix, we use boltless tokenization. And with boltless tokenization, how it works is that if you have a value X, which is a sensitive data, the value gets tokenized with a key, and it passes through our Fortanix DSM platform. It performs a FPE, which is format preserving encryption, and basically stores it within the Fortanix platform. It uses the same value, the format. Let's say if you have a 9-string value, it keeps that string of value, like how FP stands for, format preserving encryption, and it keeps it to the Fortanix database. Whereas in the bolted tokenization, as you can see, the diagram at the top, when a sensitive data is entered by a customer, the sensitive data gets tokenized within a tokenization service, and it gets linked to a database which has the equivalency. of the raw data. So when a customer needs to retrieve that data, it has to contact the database to provide that tokenization before it brings it back to the customer. So there's differences between the design, but again, the idea here is that with voltage tokenization does not rely on a database. It's a lot quicker to process. It's lower CPU. So with voltage tokenization, it's a much better platform in comparison to a voltage tokenization. So just be clear on the two differences, because some of your customers will be asking, what type of tokenization do you provide? Okay. Now let's move on to the sample workflow of how it works. It's very easy to configure, just to be very clear on that. There's two steps that you need to do within the DSM. And the first step is that you need to create a tokenized object. And the tokenized object, you could basically provide, you have to configure a key. In this example, we have AES, and you have to provide the data type. And the data type could be a custom string. In our example here, we have credit card phone number. Again, phone number varies, credit card information varies depending on what type it is. Is it Visa, MasterCard, American Express? And then you have the option to mask the patterns. If you want to mask the pattern within the configuration, as you configure your object, you could basically mask the last four, the first three, or whatever configuration you have the option to do that. Once that is completed, that object is created and built, configured in the DSM, you have to create the authentication app to the DSM. So you need to select the application that you have to tokenize. And once that is tokenized, the app is tokenized or it's been configured, you can now test the actual platform where you use an agent or a user, a customer, to basically send a request using their specific data, and then it gets passed to an application of choice, maybe a credit card entry or something, through an online purchase. And the first thing it's going to do is that the app pulls the requested raw data from the database, which you can see here, fourth step. And then once it's pulled, it goes to the DSM, where app sends the raw data to DSM, right? And then from there, we do a format preserving encryption on the DSM, which basically the tokenization is performed inside the DSM. And then from there, once the raw data is tokenized, it's sent back to the application and sends it back to the user who sends the request or whoever initiated the actual transaction. So the app sends the tokenization to the user, which is the value that they have. So as you can see here, the tokenized data is fully secured within the Fortanix DSM, which is the service that we're offering to our service providers, or the providers that we have. Now, there's a lot of different types of data protection technologies, and the most common is that encryption versus tokenization. And I basically split it into the differences based on the features that encryption and tokenization. So with the process in the data encryption, mathematical transform data plain text to a ciphertext using algorithms and keys. Where in the data tokenization, you have a randomized data and sensitive data in the database. The problem with data encryption is that once you understand or you crack the algorithm, the keys, you can basically reverse the data back to its raw state. Whereas in data tokenization, you will not be able to reverse the data because all the data is randomized, and what you're basically using is tokenizing the actual data that's basically used. So you can't reverse it. Within the data, sensitive data is converted to a cipher using algorithms, like I mentioned before. Sensitive data is not within the token. It's actually randomized data. So this is a much better data security scheme in comparison to data encryption. In the structured data, typically in the data encryption world, the large files are basically encrypted, where in the data tokenization, it's designed specifically in the string of value, where it could be a social security number, your health information number, employment ID, credit card information. So this is how the data tokenization is designed for. It's a string of value. You can customize the value that you want to tokenize. In terms of compliancy, like I said, it reduces risk on the data encryption, but it does not really comply fully. In the data tokenization, the entire data information gets fully compliant with PCI DSS, and many other different types of compliance regulations that we have specifically to data security. For data security competitors, as you can see, these different security protection products can do decryption, or they can protect some of the raw data from being hacked from the bad guys. Obviously, tokenization, we have a lot of competitors here. We have Thales, we have Voltage Secure Data, we got TokenX. Obviously, these companies can do this, and some of them just do tokenization by itself because it's a very large business for them just to protect raw data from being hacked from the bad guys. Where on web application firewall, they have also these functionality where they could mask, but not specifically tokenize. They could probably encrypt, but not really tokenize. You have your CASB from Netskope, BitGlass, Zscaler. They have data protection capability, but not very similar to our functionality where we could do tokenization. And then DLP, data loss prevention boxes or cloud solutions can also do these, because that's their actual platform solution, but does not have a very refined solution to protect data or raw data security from the bad guys. Where in our solution, we are a boltless architecture solution with no infrastructure change. We just basically, if you want to build a tokenization platform, you can either use our cloud-based solution, on-prem solution, and there's no code change. We don't have to change our application or customer's application to comply with our tokenization functionality. It's a transparent deployment. It does not require any code changes. Again, there's no special need of, oh, by the way, you need to put a colon every string that you need to parse. We don't have to do that, because what we do is we scan every single digit and be able to tokenize it based on the values provided that we need to do. We have flexible licensing, and this is very critical, because as you can see on the web application firewall and CASB, some of these vendors rely on revenue based on the throughput, and every data that's being parsed, that's being passed across the web firewalls, the WAF, the CASB, DLP, it can be very expensive, because as you stream this data across and be able to protect them as they pass through, it can be very, very expensive. Where in our solution at Fortanix, we have the credit-based licensing. If you buy the licensing, you could pass as much throughput as you want, given that you need to tokenize a specific data that passes through the infrastructure. And again, PCI DSS compliancy is very important, especially when you're doing a lot of credit card transactions to protect your customers' data information. And then tokenization competitive, the typical competitors that we have. But the advantage here is that you can have tokenization, 24 hours a day, but do you provide data security for all your, do you have a full-blown data security to provide HSM? Do you provide key management? Do you have secret management? Do you have encrypted decryption capability? Are you FIPS compliant? So these are the biggest things, as Fortanix provide a one-stop shop for data security functionality, where we could also do data masking, and the most important, like I said, the key life cycle management for HSM functionality, key management, and secrets are very, and also code signing is another feature that we provide. And again, FPE, format preserving encryption, this approved is very critical. Some of the SaaS solutions will have a hard time providing this certification or approval because they're cloud-based. And just to be, and again, it depends what type of either a vaultless or vaulted or tokenization feature that you have. But these are basically the common competitors that you're going to have. Fortanix is on a good area. We have a very good solution in terms of compliances, functionalities, features, and more features in terms of security management and data protection for customers' data. Again, I hope you guys enjoyed this session. Thank you for watching and listening to my video, and I hope to see you again. Thank you.